Ndikuyesera.
Mwambapo basi zikomo. Thank you. Recording has started.
All right.
Hello?
This is Ara.
Yes.
Hello.
Yes, yes.
Yes, sir.
Yeah, this is question 3, which is talking about our studio. So we have to repeat the same command as we have done in Stadia. So first we have to install packages and the library. So this cell installs and loads the Excel package, which is necessary for reading data from Excel files. Yeah, thank you. Someone can take the floor.
Right. So as you can see, hope you are talking.
I was saying could you when you scroll.
Right. So as Mike says, we have to upload the packages. So we have more than one packages that we upload there. So we have read Excel, we have to install Tidyverse, we have to install. Can you please scroll the screen? Yeah. So we have to install all those packages. Yeah. We have to install those packages for them to learn so that they can give us the results. Thank you. Someone can take from there.
Okay. Where are we by then?
On the table, it should be the table which says this cell is the data from sheet 1 of student data. Let me just explain.
Okay, yeah, you can go on.
Yeah. We should import. We should input student data, the file which we was given. Then we import. Then after import it, then we should read the data from the student data. After reading it, then they would even make another command after reading it. That command only says we should read it. In other words, we should display the data which is in student data.
Okay, that's fine. Anyone else? Hello?
Yes.
Yes.
Can you please scroll the screen?
Because what you are showing there and the explain. Then we have to rename the gen. You have to rename them.
The columns.
The columns. You have to rename the columns. So that command even rename the columns.
Which command?
It is showing the
There's
which is names the students greater than in so.
Right.
yeah, that's true.
Okay. Okay, anyone else?
You, my friend, you have to explain.
So after as we can see there, the like we upload can you
After
scroll?
renaming,
Yeah, after renaming me, I can see that there was the command of summary, which which summarizes the gender, program, and family type, which shows us the mean, the median, marks, and so on and so forth. So as we can see on the screen, as the cell provides statistical summary of the age variable in the student data frame, including minimum, maximum, mean, median, and the quantiles, helping to understand its distribution. Yeah, thank you.
Yes. Scroll down, my guy. Scroll. There.
Yeah, I think after we have done the summary of gender and of gender age, we go on a uh, summary statistics, and it says this cell calculates summary statistics on count, mean, standard deviation, minimum, and the maximum for the age variable grouped by gender, and it's provide insights into age distribution across different genders. Yeah, I think that's it.
Okay.
Yeah.
Yeah, let me just add up.
Yes, Adam.
That cell installs and loads the package called Woodridge, the package called Woodridge, which contains data sets commonly used in econometrics, and then loads wage one, which is the data we was given also.
Okay, fine. Okay.
Yeah.
Oh.
That is the command you might pass here.
I think now we're going on a or OLS regression
Yeah.
results.
But we should do the regression first after. I mean, before the results.
All right.
Mm.
This is education.
That is the summary for OAS. Then you can scroll up. Yeah. That's it. You can just scroll up a little bit. You should see the command. Before running the OLS, we should install the packages for Woodridge and the libraries for Woodridge and input data, which is wedge one. After doing that, then Tivangano learn OLS regression. The OLS regression will run on education experience and tenure. Yeah.
Yes.
Yeah, that is the data showing down there.
Can you scroll down?
So the data displays a detailed summary of model OLS regression, including coefficients, estimates, standard errors, p-values, R-squared, and F statistics, which are crucial for interpreting the model's performance and significance. Someone can take it from there.
All right. Scroll down.
Okay, so we have to put the command which says BP test, which is model underscore OLS. So when we learn that model, it is going to give us that data summary, which says student yeah, something is that like that. So this test usually checks for heteroscedasticity, which is non-constant variance of residues, which is an important assumption of in OLS. So that test it helps to check heteroscedasticity. Yeah. Anyone to add?
I
All
think
right.
that's
Thank you.
you can scroll down.
All right. We are doing a diagnosis test. We talked about a model OLS of Brecht Pagan, and now we'll go on residuals. So on residuals,
Yeah, Mike, go on.
all right. We use that command which says residuals or OLS. It says that this cell extracts the residuals from the model or LS and then performs a normality on the first residuals. So this test access whether the residuals for a normal distribution. Yeah, I think someone can take it from there. Yeah, that's it. But people, are we here?
Yes, we're here.
I just only hear your voice. I'm not talking about you. People, let's be interactive here.
Myself,
I only hear promise, hope. Where there are others?
appreciate. Myself, so you can explain the graph. You have to put the graph. I think it should be. We should put a graph for model LSC uh, and the residuals in the a B line. Yeah, a B line. Scroll down.
Uh, Actually, I can see the screen. Are you scrolling down?
Yes.
So the graph shows it's not a graph for such, but it's a scatter plot of fitted values against the residuals from the model OLS. The horizontal line at the y is equal to 0 is added to help visualize, detect patterns that might indicate heteroscedasticity or other variation of OLS assumptions. I think that's it. When we can go to the other one.
Hello.
Is this like still around?
Hello.
Yes.
Where are we?
After the scatter plot. Yeah, right there. Yeah.
Okay, I think the question says we should use the website data, which is web use. So there's a link there. I think that will work on.
Yeah. So if you open the link, then yeah, you can scroll down.
I think thieves are outside. Someone should go and check.
Where?
I can hear dogs barking. All right, we can proceed, guys.
All right. So we have to input command which says is it one or LBW?
Hello.
It's LBW.
Right. So we have to input the command which says LBW greater than minus symbol web use and so on. So this cell defines a helper function web use to easily load data set from a specified URL using the Haven package. It then uses this function to load the LBW, which is low birth weight dataset. So after that, we have to input another command, which is in the in our cell. Of course, I hope you can see that. I cannot mention it all. So in this cell, that command converts the less variable in the LBW dataset to a factor. Then it feeds a logistic regression model, which is GLN, with a binomial open bracket link is equal to logit to predict low birth weight based on age, race, and smoke. So after that, we have to input another command which says summary on the logit model. So after summary, it will give us those figures. So these figures are coming after summarize that logit model. So as we can see, there are a lot of figures. We have estimate, standard error. Can you go back a little bit, please? Yeah, so as we can see on the summary, we have like estimate, standard error, z value, probability, and so on. And on the other part, we have age, race 2, race 3, smoke, which was summarized. Yeah, so I think someone can take it from there. Yeah, as I was saying, the cell displays a detailed summary of the logit model, as we can, as I was saying, the summary was about logit model. So, a summary of the logic model, logistic regression, including coefficients, estimates, standard errors, z values, p values, and other model fit statistics. Yeah, that's on their side. So we also have to input another command, of which you can see it. So after running that command, we have some figures, which is on our screen. So it says the cell calculates the exponential of the logistic regression coefficients, which use the odds ratios, and the odds ratios are easier to interpolate the low logistic regression coefficients, representing the change in odds for a 1 unit change in a predictor. Yeah. So someone can take us up on the another command. Thank you.
All right. Thank you. Mwaza, Madam Promise. Mwaza inuyo. I think you can scroll down.
I'm looking.
All right. I think I'll just continue where Promise stopped. So there's a command there which says old web use odd. So this cell loads the auto data set using a previous defined web use function. So we use that command to define the web use helper function. Scroll down the screen, please. All right, I think that's it. We can see that there's a in web use data we have price, lab, foreign, and MPG. So if we click summary model what, we have this output. Scroll down, please. Yeah, so the results it fits an OLS regression model which predict price, which based on a MPG. These are the variables that they are in a web use data. There's a rep 78, and there is also foreign variable. So it then displays the summary for this model. And then we have a plot. Our plot model which displays residuals and our fitted values. Our fitted values on price, rep 78 and foreign and MPG. Scroll down. Yeah, then we use the command of Summer logit model. Yeah, before Probit, yeah, yeah. I think that's it. We use a Probit model on foreign weight and kgs in kgs. Weight which is expressed in kgs and MPG. Yeah. So this self is a Probit regression model with a binomial link to predict whether a car is foreign based on its weight. I think someone can proceed from there. Can proceed from summary Probit model. Yeah, thank you.
On the summary Probit model, the cell displays a detailed summary. Yeah, detailed summary of the Probit model, providing information on coefficient estimates, standard errors, zero values, p-values, and overall model fit. And the summary, we can see it above. So far we have learned a lot of commands which RStudio help us to summarize some of the models and the likes. Another thing, we put, like, I'm just concluding because of the time. So to conclude with it, the RStudio usually commanded us to install the packages, because it doesn't have packages like Stata have, because Stata we can run commands without store packages. So RStudio, for it to run those commands, it needs us to install packages. All right, so we have done like print of models, like we can see as we go down. So this is our presentation on RStudio and all the commands that we use to learn. Thank you so much. If there's anything you can add.
All right. Guys, are we here?
Yeah, whatever.
Yeah, we are here. We have no addition.
Mama stop buddy.
All right, let me just stop the recording.
Panga stop.